expected in your examination. So Einstein's model of specific heat. The earlier model was given by DeLong and Petit, and it is known as classical model of specific heat, where you found that the specific heat is equal to 3R, that means constant. Specific heat is having constant value. But does this value of specific heat that has been derived classically, is this holding good in agreement with the experimental results or not? With experimental results or not? So we have found that these classical results are violating the experimental factors, particularly at low temperatures. You are performing experiment for specific heat, you are getting other result what the classical theory is predicting, particularly at low temperatures. So afterwards, two important models. One is Einstein's model of specific heat and another one is Debye model of specific heat. These two models were basically based on quantum mechanical theory. You are taking quantum mechanical oscillators into consideration and you are trying to find out the specific heat expression. Then you will find out two cases which will arise. One at low temperatures, another at high temperature, and we will see whether the specific heat at low temperature as well as high temperature is in agreement with the experimental results or not. So Einstein's model of specific heat basically the atom is in a solid. Here the atom is in a solid or considered as oscillators, and these oscillators are vibrating. Independently with same frequency. This is basically the assumption on the basis of which Einstein derived his specific model of his model of specific heats. First, we have assumed that atoms are in a solid are considered as oscillators. Then we have also assumed that they are vibrating. These atoms are first treated as oscillators, that means atomic oscillators, and they are vibrating independently with same frequency. This is the main difference between the Debye model and Einstein's model. Einstein's model has considered independent oscillators, while Debye model is considering them as coupled oscillators. This is the main difference in the assumptions on which the two models have been formulated. So atoms in solid, first they are considered as oscillators, atomic oscillators, vibrating. These oscillators basically vibrate independently with same frequency. So what we are doing, we are basically using quantum mechanical results of oscillators. Basically these oscillators are atomic oscillators. These atoms are basically oscillators are basically atomic oscillators. So average energy average energy associated with one dimensional harmonic oscillator is given by average energy represented by E bar, and it is equal to h nu by e raised power h nu by kt minus 1. Because this result we have got from the Planck's quantization of energy. Well, we got the result for harmonic oscillator as h nu by e raised power h nu by kt, where you know h is Planck's constant. So nu, you know, the nu is the frequency, k is Boltzmann's constant, and T is the temperature. The Planck found the average energy associated with a one-dimensional harmonic oscillator h nu by e raised power h nu by kt minus 1. So this was for one-dimensional harmonic oscillator. If you are having n three-dimensional oscillators, for n three-dimensional oscillators, what will be the energy? It will be equal to 3n E bar. 3n E bar will be the energy. Okay? See, basically, as we were discussing from yesterday, that we have to basically find out the specific heat at constant volume, because in solids when we refer to specific heat, we usually refer to specific heat at constant volume. So, because you know that in case of the gases, you usually take Cp. Cp is used for other systems where the interatomic or intermolecular separation is large in comparison to those where you are having the small intermolecular or interatomic separation, as in case of the solids. So we are taking always Cv, the specific heat. What is Cv? Yes. Cv is equal to, you are having your Cv is basically, what is first the total energy of 3n dimensional oscillator is, it is 3n h nu by e raised power h nu by kt minus 1. We are just replacing the value of E here. We are substituting the value of E bar in this equation that we have written already. Okay, so your total energy will be 3n, your total energy. This is your total energy. It is represented by U, and it will be equal to 3n. For E bar, you are substituting the value h nu by e raised power h nu by kt minus 1. Hope up to this point you have got, huh? Okay. Then what is our aim? Our aim is to find Cv. What is Cv? It is change in total energy with temperature. Change in total energy with respect to temperature, you are getting the Cv, specific volume. Okay, specific heat at constant volume. So how you will represent this equation? You will write down, it is basically d by dt of 3n h nu e raised power h nu by kt minus 1. This is the result that we got. So we have to differentiate this function with respect to temperature. With respect to temperature, it's not time, it is temperature. So what will be your result? Cv will be equal to, see, 3n h nu is basically constant. 3n h nu is constant. I am taking it out, so you are having inside d by dt of e raised power h nu by kt minus 1 raised power minus 1. Okay? You want to write this setup in this way? So now you can differentiate the things. 3n h nu. See, it will be e raised power h nu by kt. First minus 1 will go down. Minus 1 will go down. N into x raised power n minus 1. If you are having a differentiation of x raised power n, you are having differentiation of x raised power n, you write down it n into x raised power n minus 1. Similarly, minus 1 will go down. So you are having e raised power h2 by kt minus 1. It is here minus 2. It's here minus 2 because minus 1 is minus 2. But there will be internal differentiation of e raised power h nu by kt. It will be e raised power h nu by kt because differentiation of e raised power x is always e raised power x. But there is an internal factor. You will get another factor for the differentiation. That is this part. It will be d by dt of h nu by kt. H nu by kt. Up to this point, are you following? Do you have any confusion up to this point?
सर माइनस 1 भी है ना?
माइनस 1 आया ना?
सर वो इंटरनल माइनस 1 ना?
हाँ वो यहाँ माइनस, ठीक है? So what is your CV? CV is equal to 3n h nu. H nu by k, another h nu by k, because h nu by k is constant. H nu by k is constant. I have taken it out of the derivative. So you will write down this step as e raised power h nu minus e raised power h nu by kt divided by e raised power h nu by kt minus 1 raised power 2. Okay? मैंने इसको नीचे ले लिया है मैं तो प्लस 2 हो गया. माइनस 1 यहाँ ही है तो माइनस यहाँ ही रखा मैंने. अब यहाँ है d by dt of 1 by t. That is minus 1 by t square. Minus 1 by t square. Okay, you first write down these things, then I will move ahead, move forward. अब आप देखिए आपका एक्सप्रेशन क्या बन जाता है. सो योर एक्सप्रेशन इज नाउ CD इज इक्वल टू 3n k में यहाँ इंट्रोड्यूस कर रहा हूं, यहाँ h न्यू स्क्वायर, h न्यू का होल स्क्वायर डिवाइडेड बाय यहाँ k स्क्वायर. ठीक है. सो इनसाइड यू विल बी हैविंग e raised power h nu by kt divided by e raised power h nu by kt minus 1 raised power 2 square. Okay? But here it will be, here it was minus 1, minus times, it is here minus 1 by t square, minus 1 by t square. Differentiation of 1 by t is minus 1 by t square. Shall I rub this stuff?
Yes.
अगर कहीं डिफिकल्टी हो रही है तो प्लीज कन्वे. So C is equal to, now I will take, see, minus and minus will become plus, minus and minus will become plus. 3nk, it will be h nu by kt square. T square I will be taking, 1 by t square I will be taking out of the brackets, out of the square brackets. So it will be h nu by, h nu is having square, k square and t square. So I am writing h nu by kt whole square. So inside you are left with e raised power h nu by kt raised power h nu by kt minus 1 का whole square. So this is the result that you got for this specific. I will further say what is nk. Nk is 3r. Nk is r. Nk is r. So you are having h nu by kt e raised power h nu by kt divided by e raised power h nu by kt minus 1 whole square. This is the result that we have got for specific heat. Now, we are taking into supposition that h nu by k is equal to theta e. H nu by k is equal to theta e. So you will be having Cv is equal to 3r, it is theta e by t ka whole square. Okay? What will be the second term? It will be e raised power theta e by t divided by e raised power theta e by t minus 1 का whole square. Where theta is Einstein's temperature. Or theta is Einstein's temperature. Then this is equation. This is equation. Equation number 2. And okay, equation number 1. This is equation number 1. Now, this is the expression that we have got for specific heat. This is the expression for specific heat. We're taking into the assumption that atomic oscillators vibrate independently but with same frequency. So, two cases arise. So you remember this expression, then we will try to solve our two cases of the specific heat. Case 1 is two cases arise. One is at high temperature. Another is at low temperature. Oh, let us take the case first. So case first. Case first is temperature is very large than theta e. Temperature is greater than theta e because at high temperature. First case is at high temperature. Go at high temperature. At high temperature. Temperature is larger than theta e. That implies that is theta e by t is less than 1. Is smaller than 1. Because you can write this expression as theta e is less than t. This can be written this way. Theta e is less than t, or theta e by t, it will get divided less than 1. That's what I have written here. Now let us take case first. So we are having e raised power theta e by t. Can I write this e raised power theta e by t as 1 plus theta E by T plus so on. Plus, do you have any idea why I have written this in this form? Very good. E raised to power x. You are having, for x you are having theta E by T. So 1 plus theta E by T, then theta E square by T square, 2 factorial, then plus so on and so forth. Okay? So in this case, or I can write down this way. E raised power theta E by T minus 1. I am taking this 1 here, minus 1 equal to theta E by T. Theta E by T. This is nearly equal to theta E by T. Because, okay, now what you have to do, you have to substitute this value in this equation. So your CV will turn out to be 3R theta E by T whole square, or theta E by T, okay? Then you are having E raised power theta E by T. You are having here in the denominator E raised power theta E by T minus 1 ka whole square. But your E raised power theta E by T minus 1 is equal to theta E by T ka whole square. So this and this will go. This and this will. No, E is subscript. It is a subscript. Einstein's temperature. It is subscript. Theta E is subscript. So CV is equal to 3R. And you are having another term E theta E by T. Or I can write down CV is equal to 3R. But what is E raised power theta E by T? Again, 1 plus theta E by T plus so on. But if you look at, we have given the assumption that theta E by T is very less than 1. हमने पहले ही assumption दे दी at high temperatures theta E by T is very less than 1. That means this term, the terms on the right hand side of 1 can be neglected in comparison to 1. These all the terms which are, again I have expressed this e raised power in terms of e raised power x 1 plus x square by 2 factorial plus x cube by 3 factorial, so on. This, so 1 plus theta E by T plus so on. But this theta E by T, we have already provided an assumption that theta by E by T is less than 1. So that means 1 is very large quantity in comparison to theta E by T. So this theta E by T can be neglected. So CV is equal to 3R, inside bracket only 1 is there. CV is equal to 3R. What is this CV is equal to 3R? So at high temperatures, your specific heat is having constant value is equal to CV is equal to 3R. It is having constant value, CV is equal to 3R. But this value we already know. This value we already know from classical mechanics. From Dulong-Petit's law, where your CV at high temperatures is equal to 3R. It is having some constant value. It is having some constant value because R is a constant quantity. R is constant quantity, 3 is constant quantity. So that means at high temperatures, your results are clearly in agreement with the classical model. Even though you are applying the quantum results, you are applying the quantum results. Now let us try to find out whether this is happening. The same is the case with when temperature is very less than the theta E. So let us move to that case, okay? Shall I rub this?
Yes, sir.
Have you jotted down all of you?
Yes, sir.
All of you have jotted down this thing? Okay. Any confusion or any question? So you can write down in your own words that at high temperatures, CV is equal to 3R, it is in agreement with the classical results provided by Dulong and Petit. Now we are having case second. Your case second says temperature is less than theta E, or that means theta E by T is greater than 1. So when temperature is less than theta E, that means theta E by T is greater than 1. Okay? Now we have to find out what are the results when temperature is less than theta E. So you can see, we know that e raised power theta E by T minus 1 is equal to, it is greater than 1. It is greater than 1. I can write down theta E by T only. Now, the inverse thing happens. So, this quantity is much greater than 1. So, we can write only this quantity, 1 can be neglected. In the previous case, this quantity was theta E by T, not exponential, but theta E by T was very, very less than the 1. So, we neglected the theta E by T. But here we are neglecting the exponential term, because exponential term is, it is very, very large than 1. Okay. So now you can substitute the values. CV is equal to 3R theta E by T cos square whole square, and you are having e raised power theta E by T. You are having e raised power theta E by T ka whole square. This and 1 will go. E raised power theta E by T will go with 1 e raised power theta E by T. So your result is CV is equal to 3R. It is 3R theta E by T square into, I can write down, it is 1 by e raised power theta E by T, or you can write down this CV is equal to 3R theta E by T whole square e raised power minus theta E by T. So in this case you are not getting the result only 3R, but you are having some additional terms like theta E by T square and e raised power minus theta E by T. It suggests that it is the specific heat is varying, decreasing exponentially. This is an exponentially decreasing function. This is an exponentially decreasing function here. So theta E raised power minus theta E by T, specific heat indicates that your specific heat is decreasing exponentially. So, but when you perform the experiment on specific heat of solids, you observe that this is not the real thing what you are getting experimentally. This is the limitation of Einstein's model. Einstein's model is having a limitation in second case, where your temperature is less than theta E at low temperatures. It is not in agreement with the results that you are obtaining during experiments, because experiments show you entirely different results. Experiments show you that the CV at low temperatures, this CV at low temperatures follows T cube law. It follows, it varies cube of temperature. It varies as cube of temperature. This is known as Debye's T cube law. Debye's T cube law. So at low temperatures, so even the desired results that we were trying to get, we are not getting even by using what you call the Einstein's model of specific heat. So that means there needed to be some sort of modification in the assumptions that we have introduced here. We have introduced the assumption that solid is consists of atoms, that we all agree with. It consists of atoms, but these atoms are treated as atomic oscillators. We already agree with it because you are treating basically the atoms in the solid as atomic oscillators. They oscillate. Once the deformation takes place, they oscillate. What kind of whatever kind of energy we can provide to it. These atoms basically oscillate within the system, within the crystal. So these are treated as atomic oscillators, but with one flaw. Einstein has taken these as independent oscillators. So, because he has not taken into consideration the influence of one on another, because you are having some bound system there, where you are having regular and periodic arrangement of atoms, you are taking the atoms oscillating independently. It does not make any sense. It makes sense when you take as the coupled oscillators, influence of one over other. So you are treating them as coupled oscillators, then you are trying to find out the number of degrees of freedom in different modes, translational mode and vibrational mode, then you are trying to solve out the problem. This problem has been solved out by debate. So tomorrow we will be following this debate if you take your law. Okay, I'll be winding up my lecture here.